Hello everyone, welcome back. So today we will continue doing partial fraction. Now yesterday, my friend asked me, what if we encounter this situation? We have a repeated linear factor. This means x plus 1 multiply x plus 1. So, is that equal to x plus 1 over a? Can we write that into this? Can we? What do you think? Now let me tell you, this is absolutely wrong. Why? Because if you combine these two fractions together, we will get x plus 1 over a plus b instead of the squared version. So that we cannot write this into this. Instead, this is wrong. Instead, we write this into x plus 1 plus x plus 1 squared. Now when we combine these two, we will get the x plus 1 squared as the denominator instead of x plus 1. In fact, if you have x plus 1 to the third power, we need to write that over something. We need to write that into x plus 1 over a plus x plus 1 squared over b plus x plus 1 cubed over c. We have to build up the power tower. We cannot skip any one of them. So with this concept, let's solve and let's decompose fraction. Our first question: 4x plus 7 over x squared plus 2x plus 1. Now, remember, the very first step is to factor the denominator out. So what do we get? This is a plus 2ab plus b squared. So that we can do this in our head. We get x plus 1 squared over 4x plus 7. Let me write this clear. So now we have a factor in the denominator, so that we can write this into x plus 1 over a plus b over x plus 1 squared. Now our job is just to find out these two constants. So how can we do that? We make these two fractions into one fraction so that the denominator can cancel out with the left hand side. Now a, we need to distribute 1x plus 1 into 8. And then b, we keep it as the same because it is already originally divided by it. Now left hand side keeps the same. Squared. So now we can cancel out the denominator. We get 4x plus 7 equals a x plus 1 plus b. So since this is an identity, regardless what x is, this is always true. So how can we find a and b? We substitute x equals to -1 so that this will become 0, and then the a term will disappear. This makes the equation become a linear equation with one unknown. 4 -1 plus 7 equals to a 0 plus b. Now this is -4 plus 7 is 3 is equal to b. That means b is equal to 3. Now what do we substitute x for in order to get a? Now seems that we can't make b disappear, but actually we have already solved b, so that we can substitute x whatever you like. It is already a linear equation with one unknown. I would like to sub x to 0. 4 0 plus 7 is equal to a 0 plus 1 plus b. Now this becomes 0 plus 7 which is just 7 is equal to a plus, what is b? b is 3, so that a is 4. So that our conclusion is that 4x plus 7 over x squared plus 2x plus 1 can be decomposed into x plus 1 over a is 4, plus x plus 1 squared over b, which is 3. And that is our answer. And if you want to check it, just combine them. Now we have another question. Now you have seen cubes. Okay, no matter what fraction you encounter, the first step is always to factor out the denominator. And how can we do that? I don't want to factor it in hand, so that I have prepared a program. Just type the coefficient in order: 1, 3, 0, and -4. We get 1 as a solution, so that x minus 1 is a factor. Remember to reverse the sign. And then -2 is also our solution, so that x plus 2 is a factor. Let's look at the third factor. It is also 2, -2, so that it is squared. Now we have encountered a repeated linear fraction. Let's write the numerator first. How can we decompose this fraction? We can write this as x minus 1 over a plus x plus 2 over b plus, remember, build up the power tower so that we need to have 1 squared. So now we have 3 constant. Let's copy the right hand side, left hand side for you. Now we want to cancel out the denominator, so that we will want to combine the right hand side x minus 1, x plus 2 squared. And then a need to be multiplied by x plus 2 squared plus b x minus 1, x plus 2, and then c will be x minus 1. So that now the denominator cancel out. I don't want to copy one time. Forgive me. We're left with the numerator a plus b x minus 1 x plus 2 plus c x minus 1, like this. So in order to find out a, we want bc to disappear, and apparently by substituting x equals to 1, these two terms will disappear because we make this 0 and make this 0. So sub x is equal to 1. We can get 4 1 squared plus 11 1 plus 12, and then left hand side will be a 3 squared. And now let's use the calculator. 4 plus 11 plus 12 is just 27, and then this side is 9a, so that we get a is equal to 3. Now a is equals to 3. If we want to find b, we want c to disappear. How can we do that? Oh, maybe we will find c first. You will see why. In order to find c, we will want b to disappear. And if we substitute x to 1, c will also disappear, so that we will substitute x to -2. Now 4 -2 squared plus 11 -2 plus 12 is equals to a is 3. -2 plus 2 is 0. So it's a 0. And this is also 0, plus -2 minus 1 is -3c. So that we are left with 4 times 4 plus -22 plus 12 equals to -3c. Let's use the calculator. 6 is equal to -3c, so that c is equals to -2. Let's use another paper. Now c is equals to -2 and a is 3. We are left with the b term. We can substitute whatever we like except 1 and -2, because this will cancel out the b term. So that we can, actually I don't need to compute once. Substitute whatever we like, and I would like to substitute 0, because it's always going to cancel out some term. 4 0 plus 11 0 plus 12 equals to a 2 squared plus b -1 2 plus c -1 Now left hand side is left with the 12, and then right hand side will be 4a plus, oh maybe minus 2b minus c. Now a is 3, so that 3 minus 2b minus -2. Now this is 12 plus 2, and we are left with this one, so that we can see that b is equal to 1. So we can already make our conclusion because we have already find out the free constant. Let's look at this. X minus 1 over a, which is 3, plus x plus 2 over b, which is 1, plus x plus 2 squared over -2. Now this is our answer. So that's the end of the video. Now the very last conclusion is that remember to build up the power towers for repeated linear factors. Thank you.